What comes to mind when one thinks of Antarctica? Perhaps images of icebergs and glaciers would be fitting, as they hold about 90% of the ice on Earth. Or possibly a unique bucket list destination where one might catch a glimpse of penguins or dolphins. Or maybe a recognition of the essential role that polar regions play in the global climate change. While these perspectives are valid, the reality is that Antarctica is changing rapidly, with ice melting at a rapid and concerning rate, driven by rising global temperatures and increasing greenhouse gas emissions that has even climate scientists worried. And we should be too. Approximately 40% of the global population lives within 100 kilometers, that is 62 miles of a coastline, according to Earth Science data systems. As polar ice melts and sea levels rise, leading to more extreme high tides, coastal flooding is becoming more frequent and severe. This growing threat underscores the urgent need to address ice melting in the polar regions, which has not yet received the attention it deserves. Human activities that elevate greenhouse gas levels are accelerating ice melting worldwide. The burning of fossil fuels, deforestation, and industrial activities release large amounts of CO2 and CH4, which, combined with existing carbon in polar regions like Antarctica, traps heat and contribute to global warming. The effects are even stronger in polar areas, where rising air temperatures directly melt glaciers, ice sheets, and sea ice. Moreover, oceans absorb excess heat, warming the water and further accelerating ice melting from below, particularly in polar regions. In examining the accelerated ice melting in the polar regions over recent decades, Dr. Sudhi, a climate scientist with the iHARP program at UMBC, found that the ice-sea loss began in 2015 in the Antarctic region over the Southern Ocean, causing the sea ice minima to reach the record low in February 2023. Ice sheets over the land experienced a very high rate of melting, marking a rise from 1,989 gigatons from July 2018 to 2,797 gigatons in January 2021. That is 800 gigaton loss in just 3 years, compared to just 147 gigaton per year since 2002. During the same time, there was an uptick in Amazon wildfire events. The Amazon wildfires, which gained global attention, were driven by both natural and human factors. However, the anthropogenic factors were primarily driven by deforestation and land clearing for cattle ranching and soy cultivation using the slash and burn method. Illegal logging intensified deforestation, making the forest more prone to fires, especially during the dry seasons. Weak enforcement of environmental regulations and government policies in Brazil, coupled with international trade pressures, consumer behaviors, and rising global consumption, especially in the West, collectively contributed to the environmental crisis in the Amazon. In the wake of the wildfire events, Dr. Sudhiv's scientific inquiry revealed that 10 more black carbon aerosols, atmospheric rivers, which symbolizes extensive transport of significant amount of aerosols, were transferred from the Amazon to the Antarctic in 2019, as compared to 2018. This evidence spanned across 5 polar regions in the Antarctic Basin: the Ross Sea, the Weddell region, the Indian Ocean, the Bell-Amundsen region, and the Pacific Ocean, with the effect being stronger where the melt is higher, particularly in the Weddell and Bell-Amundsen and the Ross region. Many other factors can cause sea ice retreat. However, a possible connection needs to be teased out because wildfires release aerosols, including black carbon, also known as soot, and dark particles that can travel long distances through the atmosphere. When these particles reach polar regions like Antarctica, they settle on the ice, reduce its reflectivity, also known as albedo, and cause it to absorb more sunlight. This exposure can lead to further melting, exposing more ocean or land underneath. As additional soot arrives, it further reduces albedo, leading to even greater energy absorption and accelerating polar ice melting. The darkening of snow by black carbon aerosols amplifies the greenhouse effect, doubling the rate of ice sheet melting. Albedo is crucial in protecting polar ice by reflecting most of the incoming solar radiation, helping to maintain cooler temperatures and slowing the melting process. It also plays a key role in regulating Earth's climate by balancing global energy and controlling atmospheric temperatures. The significant loss of sea ice extent, which is the ocean area with at least 15% ice coverage, in 2019 was particularly evident on days with high black carbon presence compared to days without it. Sea ice is a protective blanket to the ice sheets. Without it, warmth will engulf the Antarctic and melt it faster. No kidding, the Antarctic ice stores equivalent to 200 feet of water. With the change in the political landscape in Brazil in 2022, the occurrence of anthropogenic wildfire event is now under better control. Interestingly, there has also been a reduction in ice sheet melting. The average melting has reduced to 139 gigatons per year. Can you believe it? It is less than the prior average. This loss could have been due to continuous and steady melting rather than extreme melting events. The scientific evidence highlights an urgent need for action, as coastal populations are increasingly affected by the rising sea levels and intensified flooding. The connection between deforestation-induced wildfires in the Amazon and accelerated ice melting in Antarctica requires detailed exploration to address the global scope of these environmental issues and the necessity for coordinated efforts. Given the impact of the ice melting extending far beyond Antarctica, the question remains, how can we reduce our carbon footprint by addressing carbon dioxide and methane? Small changes in our choices can lead to bigger impacts for the planet.